Question 30b. A golf ball is hit from point A to point B, which is on the ground as shown. Point A is 30 metres above the ground and the horizontal distance from point A to point B is 300 metres. The path of the golf ball is modelled using the equation h equals 30 plus 0.2d minus 0.001 d squared, where h is the height of the ball above the ground in metres and d is the horizontal distance of the golf ball from point A in metres. The graph of this equation is drawn below. Part 1. What is the maximum height the ball reaches above the ground? Now the vertex of the parabola represents the maximum height of the ball above the ground. So locate the vertex and from that point project across to the y-axis, and we can see here that the maximum height of the ball above the ground is 40 metres. Part 2. There are two occasions when the golf ball is at a height of 35 metres. What horizontal distance does the ball travel in the period between these two occasions? So firstly, let's locate 35 metres on the y-axis. Then we're going to draw a horizontal line across with a ruler and find the 2 points where it intersects with the parabola. So there's a point here and a point here. From these 2 points, we're going to project downwards, parallel with the y-axis of course, until it strikes the x-axis, and it's going to strike the x-axis here at these 2 points. The x-axis represents the horizontal distance. So the two horizontal distances that we have, 170 metres and 30 metres. And part 2 asks for the horizontal distance between these two occasions. So 170 minus 30 is equal to 140 metres. Part 3. What is the height of the ball above the ground when it still has to travel a horizontal distance of 50 metres to hit the ground at point B? Let's locate point B. So that's point B there at the 300 metre mark. Go back 50 metres. So 300 minus 50 is 250 metres. So locating that point on the x-axis, we're going to draw a vertical line straight up till it strikes the parabola. And from that point, project across to the y-axis, and then we can read the height of the ball above the ground from the y-axis. So that corresponds to 17.5 metres, or roughly 17.5 metres. Part 4. Only part of the graph applies to this model. Find all values of d that are not suitable to use with this model and explain why these values are not suitable. Let's go back to the graph. This is point A, so this is where the golf ball starts, and this is point B where the golf ball ends. So this point here, the golf ball's on the ground. At this point here, it's on the top of a cliff. Now, since the golf ball starts at this point, it makes no sense to have negative distances. So in fact, the journey of the ball starts here, so values of d less than 0 are not suitable. Now the golf ball ends its journey at this point here. And for the same reason, it makes no sense to have values of d that are greater than 300, since this is the point where the golf ball stops. In fact, values of d greater than 300, according to this model, indicate that the ball is in fact underground, and that's not the case. So this model is only valid for values of d between 0 and 300, including, of course, 0 and 300.